du dx. So we have to differentiate sine x from the standard derivatives. If you differentiate sine x, you're going to get cos x. Hi guys, in today's class we'll be talking about quotient rule. We are going to be solving some examples on it, which clearly shows how to apply the formula. So what do we do today? Now, I just want you to realize that quotient rule comes from a certain variable. Now, for product rule in the previous class, we used y equals uv. That was for product rule. But in this case, for quotient rule, it's a different thing, because for quotient rule, it's going to be a division. So in this case, you'll be having y equals uv. Now, what this leads to is a general formula, which is dy dx. You have a dy dx equals v du dx minus u dv dx over v squared. If I have this, then it shows that I can use this formula to solve multiple questions. But don't forget that this came from y equals u over v. So let's take examples. 1. If I have y equals sine x, over cos x, now the question is find the y dx. Find the y dx. This is a very straightforward question because there's a pattern we'll use to solve this, and that's using the formula. Don't forget the formula, it's dy dx equals v du dx minus u dv dx over v squared. So this is the big formula. Right here, we are going to spot what exactly is u and what exactly is v. So this is u and this is v. So this is u and this is v. So since this is u and v, so we are going to substitute them into the formula. So when you substitute them into the formula, this leads to dy dx equals, what's your v? Your v is cos x. Don't always forget to put your brackets. Now, what is u? Ordinarily, u is sine x, but right here, what we are having is du dx. So we have to differentiate sine x from the standard derivatives. If you differentiate sine x, you're going to get cos x. Minus, what is u? U is another sine x. But your v is cos x right here. So since v is cos x, so it means that my dv dx will be a minus sine x over what? V squared. So we are going to locate what v squared is exactly. V squared is cos x. So since v squared is cos x, that will be cos square x So if this is done, I mean, that's very simple. I believe you understand how this came about. When you have a square, let's say you are putting a square in brackets. So that's a combination of a times a. Are you with me? Of course, there's something you cannot see which is more or less like the powers. So you add it up, that gives you a square from indices. That's exactly how we got this. So if I take this up, so this will be dy dx equals cos x times cos x gives you cos square x plus minus sine x times minus sine x gives you plus sine square x. That gives you plus sine square x. So if you have plus sine square x over cos square x. So at the end of it though, this leads to, from trigonometry identity, cos square x plus sine square x gives you what? 1. So this is 1 over cos square x. So finally, because we know from trig that 1 over cos x is sec x, so it means that 1 over cos square x will be what? Sec square x. So your final answer is dy dx equals sec square x. So that was straightforward enough. That was what? Straightforward enough. Now let's take a look at another example. Let's make this example 2. Now, for example 2, I would like to work with polynomial function and exponential function. I can work with any of the functions. If y equals x squared over e raised power x, question is find dy dx. The formula still remains dy dx equals v du dx minus u dv dx over v square over v square. So if you have this, then it means that I can easily come here and spot what is u and what is v. So the question here is, what exactly here is v? That was exactly what we did in the previous one. So your v here is ex. Then in brackets, your u is x squared. But when you check this out from the formula, it's du dx. So it means when you differentiate x squared, you're going to get 2x. Now, if you have this minus, what's your u? Your u is x squared. So it means that I'm going to be having x squared directly here. Now, you have dv dx, but your v is what? Ex. So dv dx, there will be ex. Over, what's your v squared? You're having a v squared, so that's e x all raised power what? 2. So at this point, we are going to have it very simple because from here I can just decide to say that I need to bring out the common terms. My dy dx Now what's common here? EX is common here, EX is common here. You can even extract one X from here, because I have X, 2X here, and I have X squared here. So I can say this is EX. Then what am I extracting again? I'm extracting X out of it. I can come here and put the X here into brackets. Then what will be left here will be 2. Then minus. What will be left there will be X. Yes, we are correct. X over. Then you have this. So you have EX all raised power what? 2. From what is written here, you can observe that I can cancel out one of these out of this. So eventually, I'll be left with the y dx equals x. X will be remaining. So since I have x into brackets, two minus x over e raised by x. Why is e raised by x? Because I just cancelled one out of this, so I'm left with e raised by x. So thank you so much, guys. Thanks for staying to this moment. See you in my next video. Bye.